Okay, welcome back to antibody identification. So I want to try and do one more with you, a little slower. So I have filled out our reactions, and I've gone through and recorded them as if we were testing them within the gel system. One thing I do want to make note is when you are doing a screen, so this is a result screen here, down on the bottom over here, you want to make sure that you are recording your results on the screen antigram. Blood banking is direct entry, so we want to make sure that you are doing that appropriately. So I'm going to change my size here. Alright, so as you can see, we have some reactions. So we're going to go through and we are going to cross out on our negative reactions, which are these here and these. So we will cross off, so cell 3 and 4. So by this this is how we are selecting our rule out cells. And we are crossing off, so this first one, we're crossing this off. Sorry about that, my phone is ringing. People are texting me. So we cross off this first row. All right, so that means that we're crossing off that plus sign because that's indicating, the plus indicates a presence of an antigen on a red cell. So the fact that we have 0 reactivity means that we are able to cross that off, and that should not be the antibody source. So we'll do all that for these. Sorry, my Apple Pencil died, so this is a little on the slower side. Doesn't like the stylus as much as it does my pencil. Which I guess is good for you guys, because you said I go too fast. Which I know I talk quickly. Alright, this is getting ridiculous. I'm going to use my finger instead. So, which is harder to do than you think. So then, we can move on and we can record. We can cross off 6 through 10. Okay, so then we'll finish the rest of these. Sorry, I just had to take a quick pause. So let's see, where are we? So 5 has reactivity, but 6 down does not. So let's go ahead. Sorry, I'm kind of missing because my finger doesn't do this so well. We skip the W's because sometimes that means that they're going to react, or it's a weaker expression, so antibodies, depending on the strength, may or may not react. So let me just finish crossing off all of the pluses on the negative reactions. And you guys have gotten this, so you definitely have this concept down because you've done that part right, but you haven't given me the identity of the antibody. And what you want to do too is, if you have a dry panel from me, you want to make sure that you tell me what rule outs you would still need, like if you didn't have enough cross-offs. And I'll explain what that means in a little bit. Okay, so now we've done all of our crossing off of our positive reactions. So at this point, our negative reactions. So at this point, what we're going to do is we're going to start on each column, and we're going to count on each column. So we're looking at homozygous versus heterozygous. So for example, cell number 1 is homozygous for big C, and cell number 3 is homozygous for little c. So what that means is that this here, if it's little c or big C, that means we have a double dose of big C reacting on the cell. Oh, this thing is awful. So then, if it were little c and it was heterozygous, we would see big C, then little c, then big C, then little c. So if the antibody were against little c, it would be weaker than say if we had all of the little c covering that. So then what we want to do is we're going to go through. Now D is just by itself, so we want to count. So we need two, for AABB, we need 2 homozygous cells or 3 heterozygous. So basically we try to find at least 1 homozygous. If we only have 1 homozygous, then we need to have 3 total rule-out cells. So this is a rule-out cell here, so cell number 3. Cell number 4 is a rule-out. Cell number 10 is a rule out, and our tech cell, if you will, that's what they call it, is a rule out. So we can cross off D. So D is not our possibility. All right, so big C. Looks like big C could be what we're looking at. So we'll kind of hold on to that. So I usually circle what I don't have any cross-offs for, because as you can see in the C column, there's no red cross-offs. So then we'll go to little c. So there's one, so number 4 is a homozygous rule out for little c. Number 3 is a homozygous rule out for little c. And then we have 1, 2, 3, 4 more. So no little c here. So big E, so we have cell number 3 is a homozygous rule out cell, as you can see, because it's positive for big E, negative for little e. And then cell number 6 is a heterozygous, and cell number 10 is a homozygous. So we can rule out big E. Little e, we have cell number 4 is a homozygous. We have cell number 6, which is a heterozygous. So see, it's positive for little e and big E, so that makes it a heterozygous cell. And the reason, again, that we're doing this is because we could see dosage. And in this case, dosage means that double dose on a homozygous cell. So if it's homozygous, like cell number 4, homozygous little e, that means it has a double dose of little e antigen on the red cell. So if the antibody that's present is against little e, it would react stronger than, say, cell number 6, who only has half a dose of little e. Okay? Hopefully you're with me. So it looks like we have plenty of rule outs for little e. So now here the V and CW are considered low frequency, and what that means is that they are not often found on other cells, so a lot of patients don't have it, so typically they're not the problem. So here I'm confident we can just get rid of V, but if you look, CW still has some reactivity on cells that we have reactivity. So we're going to circle, oops. We're going to circle that because that's a possibility. So big K, if we look at big K, we only have 1 heterozygous. Now, just a little side note, it is very difficult to find a big K homozygous cell. The reason being is it's not very common for us to have it on our cells, but it's very common for us to have the little k or Chilano. So you can see out of this panel there's only 1 homozygous cell, and we can't use that because it's reacting. So we'll need at least 2 more rule outs for big K, so we need to find 2 more cells, and I'll tell you how we do that. So then Chilano, our little k, we have 1, 2, 3, 4, 5, 6, 7, 8. We have basically 8 rule outs, so we're all set with that. Cross that off. KPA is another low frequency, so we can cross that off. KPB is a high frequency. We have plenty of rule outs on that one, as you can see, 1, 2, 3, 4, 5, 6, 7, 8. JSA is a low frequency again, so we can cross that one off. JSB, we have 1, 2, 3, 4, 5, 6, 7, 8 again, because that's a high frequency, so we can cross that off. So then we go on to our Duffy family. So the Duffy family, we're looking at, we have 1 homozygous rule out for Duffy A on cell 6, because as you can see, it has Duffy A on the cell, but not Duffy B, which means it's got a double dose of Duffy A on the cell. And then number 8 is, again, a homozygous Duffy A, so we are good on that. So remember, we need 2 homozygous according to AABB guidelines. Duffy B now, if we move over to the Duffy B, looks like we have 2 homozygous on cells 3 and 4 and 7. So we're good. We can rule out Duffy B. JKA, 1 homozygous on cell 4, because you can see JKA is positive, JKB is negative, or JKB is not present on that reagent red cell. And then we have another homozygous at 7 and cell 7, and then down at 10 in the tech cell. So we can cross off JKA. JKB, cell number 3 is a homozygous. Cell number 6 is a homozygous. 8 is a homozygous, so we're good to rule that out. LEA, we have 2 homozygous rules out, although we really don't show dosage, but it's just habit to look for homozygous. LEB, we have 2. P1, we have 1, 2, 3, 4, 5, 6, so we're good on that. M, we have 1 homozygous at cell 6, heterozygous at 7, and a homozygous at 8, so we're good to rule that out. N, we have 2 homozygous on 3 and 4, so we're good to rule that out. Big S, we have 1 homozygous at cell 10 and 1 heterozygous at cell 6. So typically what I would do, just to be thorough, is I'd look for 1 more rule out cell for big S. Little s, we have 1 homozygous at cell 3. And where I lost my place, sorry. 1 heterozygous at cell 6, because you can see it's got little s and big S. And then homozygous 6, 7, 8, and 9. So we're good on little s. Oops, I didn't catch it. Lutheran A, LUA, we have 1. I would look for, try and find 1 more. And Lutheran B, we have 1, 2, 3, 4, 5, 6, 7 homozygous cells, so we're good on that one. XGA, we have 1, 2, 3, 4, 5, 6 rule out cells, so we're good on that. So from this, what is our identity of antibody that we have absolutely no rule outs? Well, we have 2 options here. We have big C and we have CW. So we could have a single antibody, we could have a double antibody. So now we also still need to find some more rule outs. So what this means is we have to go search for rule out cells. So what we'll do is we'll go to another panel and we'll search those out. But I'm going to show you a little something first. Well, actually, I guess we can come back to it. So if we move to the next panel, so let's remember we need a Lutheran, a big S, and CW not in the presence of C. Because let's face it, look at the pattern of reactivity here. We have this here, 2 plus, 2 plus, 1 plus. Okay, so this matches here pretty well. And then we have a weak plus down here, but that doesn't mean anything. And then we just have to make sure that this CW isn't causing any of that reactivity. So we'll have to make sure that we check on that. I'm pretty sure that it's not a big K because we need 2 more rule outs, but we have 1. And same with the big S where we have the 2 rule outs, we just need 1 more. So we will move on to the next, looking for rule outs for CW, big K, big S, and Lutheran. So here's our blank panel. So what we want to do is, sorry, I had to move here. We want to look for cells that are negative for big C. So that's cells 3 and 4 here, and 6, 7, 8, oops, maybe not the 10. All right, so let me get rid of the weak plus there. Okay, so now let's find, so basically this is a panel. We haven't used this panel yet, so we need, what did we need? We need a big K, CW, a big S, and a Lutheran A. Okay, so let's go. So now we have cells 3 and 4 we can use. So let's look at cells 3 and 4. Neither of those have K or CW. Neither have big S or Lutheran, so we can't use those. So 6, 7, 8, 9, and 10. We have another. Can rule out a big K. And not a Lutheran. So then that's on cell 7. So then cell 8 we'll look again. No CW. No big S. No Lutheran. Cell 9. We got a Lutheran. No, that doesn't work. And so, oh, hold on. Okay, so we'll look at cell 10. So cell 10, we have a big S. So the only thing we can't fully rule out is a, let's see, so we fully ruled out S. So that one, as long as we run the gel and we get a 0 on cell 9 and a 0 on cell 10. By the way, this is me running it, so I'm pretending I'm running it. And we'll run 7. So then we have 0 reactivity, which means we can cross out that, and cross out that. Okay, so we were able to rule out those things. So we will accept 2 hetero rule outs on big K because it's so hard to find a homozygous. So we will be able to rule out the big K. Some places like to have 3, so you may have to do that as well. Big S we can rule out. Lutheran we can rule out, but we could not find any cells for CW. So what our identity will be is anti-C cannot rule out CW. All right, because we can't. So when we go, so now we're going to go to another page, and I'm going to tell you, let's see if I can go back again. So when we go through and we look for our antibody proof, there are a few things we're going to do. So hopefully you can hear me all okay, because I need to bring this up to me to write. So first we're going to number 1. We're going to look for the rule of 3. And this means that we have 3 cells with big C antigen on them that react. Okay, so then you'll see agglutination, 1+, etc. Okay, and then 3 cells, oops, sorry, 3 cells without C antigen on them not reacting. Okay, so that means the results will be 0. Okay, and this proves that yes, we have our rule of 3, where we have 3 pos, so 3 pos and 3 negative that give expected reactions. So then what we have to do next is we have to antigen type the patient. So basically we run patient cells with anti-sera, and this anti-sera will be anti-big C. And then we look for reactivity. So we would expect a patient antigen type who has anti-C or anti-big C, okay, to be antigen negative for big C, okay? Because unless it's an autoantibody. If it's an autoantibody, then that takes everything up to a whole nother ball game. So then we would, if they needed a transfusion, we're going to look for red cells that are antigen negative for big C, okay? Because the last thing we want to do is give someone who has anti-big C antibody cells that have it. Because if we have cells that have it, then it would end up with a transfusion reaction, or else. All right, so you want to be careful with that. So that is antibody identification in a nutshell. Hopefully this one was a little slower and a little easier for everybody to understand. So take a look at that. Make sure that when you are giving me your results, you give me everything. You give me the screen antigram, you give me the antibody identification, and then the next antibody you get, you'll also have to do antigen typing, and you will eventually have to cross-match a unit. So cross-matching a unit, so once we do the antigen typing, patients with antibodies need a full cross match. Okay, and we'll talk about that when we talk when I do the lecture on compatibility testing. So make sure that you thoroughly watch all these steps. Go back and look at the chapter and look at the antibody identification chapter. Read it slowly. Take your time. Look at the panel, the dry panel packet I've given you. So make sure you check that out.